Okay, lesson 21A, which is our last lesson for this week. This is Thursday's lesson, March 26th. You have a quiz on Friday, March 27th. I will post more about that, where you can find the quiz, how you can access it. It will be online, and you will have the entire weekend to do the quiz. But we'll talk about that later. So how do we find the inverse of a function? So we talked about inverse when we were talking about solving equations and inequalities. Inverse means opposite in a sense. So let's kind of keep that in mind as we go along with this lesson. So for the do now, if you want to do it on your own, please pause the video here. Otherwise, press play and we'll don't press pause and we'll continue. Yep. Okay, so write each relation as ordered pairs and determine whether or not it is a function. So with ordered pairs means writing this as x, y. Okay, so the first pair on the left. So 1 has an arrow drawn to 6. So the first pair is 1, 6. The next pair is 2, 7. And the last pair is 3, 0. Okay, none of my x values are repeating, which means this is a function. All right, so relation G, we have 4 going to 8, so 4, 8. Then we have 5, 8. And then we have 6, 9. Okay, again, none of our x values are repeating, which makes this a function as well. Okay. So that's the do now for this lesson. Moving right along. Okay, the inverse, so now we're filling this in, of a function, and that can be written as f -1 of x. And -1 looks like a little bit, looks like an exponent. That's fine. It's not an exponent, but it's just so we can identify which is a function, which would just be f, and which is the inverse of that function, which would be f -1. They can be found by switching the first and second elements, x and y. So we're going to talk about that a little bit, but what that sentence really means, if I gave you the coordinate points 2, 3, the inverse would be 3, 2. So that's all that's really telling us, to switch the x and y. Okay, so from the do now, represent the inverse of relation f as ordered pairs. So relation f, so 1, 6 is first. So now it becomes 6, 1. And then 2, 7 was next. So it becomes 7, 2. And then 3, 0. Oh, it becomes 0, 3, sorry. Okay, so the opposite of what we have here. Awesome. So since the inverse is a function, you're just plugging in a function, we call this a 1 to 1 function. Right, and the reason is 1 to 1 is because when we get the inverse of the original, right, which is what I just gave you here, That means none of my x values are repeating, even though I swapped them or switched them. All right, so if I switch them and the x's still don't repeat, it makes it a one-to-one function. That means it's a function both ways, no matter which way I put it, in its original form or its inverse. All right, so now let's take a look at relation G. Relation G. So the first pair for relation G, let's pick a different color. Just like burnt orange. So relation G 4, 8 was the first. Sorry. 4, 8 was the first, so it becomes 8, 4. Okay. 5, 8 was the second, so it becomes 8, 5. And then the last was 6, 9, so it becomes 9, 6. So here we want to see if any of our x values repeat once I made this into an inverse function of g. And my 8 values repeat here, my x values. Those 8s in the x value spot, they repeat. They didn't when it was in its original form, which means yes, it was a function originally, but now for the inverse, it is not. So Lord, got me all over the place. Okay, sorry about that. Okay, since the inverse is not a function, we call this many to one function. Okay, so is the inverse relation G a function? No, it is not. The x values repeat. All right, so you try. I want you to pause the video here if you want to do the you try on your own. Otherwise, continue playing and we can move along. So is the relation below one-to-one or many-to-one? So first, let's see if we have any x values originally. So I have a 3, a 3, 4, 5, and 8. None of my x values repeat while it's a function right now. So let's look at the inverse. So if I switch 3, 6, it becomes 6, 3. That becomes 3, 4. That becomes 2, 5. That becomes 6, 8. So now that I've written the inverse by switching the x and y values, do any of my x values repeat? They do. Okay, the first x value and the last x value, that's 6 repeats, which means if it's not a function as an inverse, that means it's many to one. Okay? All right, moving on. This lesson is actually really short. And I know you have another lesson in your packet, which was 21B, but we're going to skip that. Just kind of teach you what you need to know from each lesson. And that was just a kind of day 2 to kind of catch you guys up. So if you want to do it for practice, you can. But this is the bulk of what you need to know, which is in lesson 21A. Okay? So remember, to tell if a graph is a function, we use the vertical line test. Now to tell if the inverse is a function, we're going to use the opposite, which is horizontal. line test. Okay, so using the vertical and horizontal line test to determine if the graph shows a one-to-one function. All right, one-to-one means it'll pass both tests, vertical and horizontal lines. All right, so now let's draw some vertical lines. See how many times, these are not straight, sorry. So I see so far I'm only hitting the graph one time as I draw these vertical lines. All right, which is perfect. That means that my original graph passed the vertical line test. Just leave a note for myself. All right, so now let's see if it passed the horizontal line test. And as I'm drawing my horizontal lines, I notice that it's only hitting this graph once. So yes, it passes the inverse, because that's what the horizontal line test checks. The inverse is a function. So that means, yes, it's a one-to-one function. Okay. Okay. So now let's take a look here. So let's do the, let's not use blue. Let's do the, so as I'm drawing lines here, even though my line's a little crooked, I am only hitting the graph once as I draw my vertical lines. So for the original graph, yes, this is a function. All right, now let's see the inverse passes the horizontal line test. Meaning when I draw a horizontal line, it will only hit this blue graph once. Already, I see that it's hit the graph here and here, which means it did not pass the vertical line test, which makes it many to one. So I'm going to put no, it's many to one. Okay, that's all you got to do here. So now, this, I was going to make this part of your practice, but I kind of want to help you out with the next question. So there's another graph after this where they don't give you the original graph the way this one does. So here they gave you the original function of f. The next practice problem that you have to do on your own, you have to graph the original function and then you have to graph the inverse. All right, so here I'm going to just show you how you would do that. So once you graph the original function for the next problem, like we have here in blue, okay, and I sent you guys a link on Google Classroom that lets you know or allows you to download a online graphing calculator for those of you who don't have one at home. So please, please, please check that link out because you will have access to a graphing calculator. Okay, so here we're gonna write down, or not really, well, you don't have to, but it depends. I'm going to identify all the 4 points on this graph. So this point here is -5, 6. The inverse would be 6, -5. This point here is -3, 2. The inverse would be 2, -3. This point here is 1, -1. The inverse would be -1, 1. And this point here is 6, -3. The inverse would be -3, 6. So now I'm going to plot all the inverse points, which is this side of my list. Okay, so 6, -5. So let's do it in a different color. So 6, -5 would be here. Then 2, -3 would be here. I'm going to start to connect the dots as we go along. -1, 1 would be here. And I'm going to connect those dots. And then -3, 6 would be here. And I'm going to connect the last dot. Okay. Sorry, guys. And I can't cut it off. Okay. So I now very ugly drew the inverse of the original function they gave us, right? Probably shouldn't have chose blue because the graph was already in blue, but that's fine. So all they asked you to do for this question was to draw the inverse. That in green was just a little reminder about using the link for the graphing calculator for the next question, okay? The next question again, you have to draw the original function, which is I think 2x plus 3, and then graph that. And then once you graph it, pick like, I don't know, like 4 points, the same way we did here, or a few points, and then draw the inverse. So that means you're going to switch the x and y values. All right, awesome.